Randy Swati is an ecologist with the Nature Conservancy's Landfire team. Randy joined the CNC Michigan chapter after growing up in Little Rock and received his bachelor's and master's at Northern Arizona University in Flagstaff. His scientific specialties span spatial scales, ranging from community genetics to mycorrhizal ecology and landscape scale planning. When employed as Michigan's forest ecologist, he worked with a variety of large landowners to promote sustainable management and was the Great Lakes Landfire modeling lead. Randy works to develop vegetation models and to apply Landfire products within the outside of the Conservancy. He recently moved from the northern Michigan to Chicago, Illinois area. Randy, I'll turn the time over to you.
Okay. So I am hearing an echo. I hope that you aren't, but I will plow through, and it looks like things are going okay in the chat for people. So here we go. So my goal today is to introduce you to Landfire and to hopefully prompt you to go explore Landfire data and models for your work. Landfire is a huge program with dozens of data sets and many tools, so I'll be just skimming the surface. Also, on this slide, I'm just skimming the surface of the broader Landfire program, showing you a picture of myself and the Nature Conservancy's arm or part of the Landfire program. So with that, we'll jump in. Here's some official verbiage about Landfire. And you'll notice a few things. One, we've colored the word Landfire to emphasize that Landfire is not only about fire. It's about vegetation. It's about an all-lands approach to mapping vegetation, fire, and fuels characteristics across the country. I've also bolded some words that I hope you'll remember. One unique attribute of Landfire data is that we update it every couple years. So that's important for monitoring and for keeping up to date with vegetation changes. Also, we try to use a consistent process across the country. I don't know about your parts of the world, but what I run into oftentimes is one jurisdiction, say a state or agency, will have great vegetation data, and maybe their neighbor even has great vegetation data, but they were collected in a different way or are summarized differently, so there's no way to really compare the data and look across a region. So Landfire allows for that because we've tried to map things consistently. So here's a less official intro, and while you read that, I'm going to try to troubleshoot a minute because I'm hearing myself 5 times over, so just a moment while I see if I can figure this out.
Yeah, Randy, that's something on your end, because it's several people have commented there's no echo for them, and there's none here.
Okay, I apologize for this, people. I'm going to go into my settings and see if I can clean this up. Otherwise, if I can't fix it quickly, I'll plow ahead. Okay, I will plow ahead with my echo. So a couple points here that I want to point out is I like to think of Landfire as something more than just a toolbox. It's really truly a way of thinking and a vibrant community of users. And I use the word hackers in a positive way, people who are creatively mixing and matching Landfire and local data sets to solve natural resource and conservation issues. So we invite you to be a part of that community, and hopefully today will be just the beginning for you. As part of Landfire, a broader partnership between USDA, Department of Ag, and the Nature Conservancy, the Nature Conservancy had an agreement to describe what we call reference conditions for all the ecosystems of the United States. I'll go into this in a fair amount of detail today because I feel like this connects with ecological site descriptions and other work that you guys may be doing. So we described how more than 1,300 ecosystems looked and worked prior to major pre-European settlement, or major European settlement, I should say. We know that changes across the country, but this is the sort of era that we're trying to represent with our models, descriptions, and data, the historic data, that is. Interestingly, to me, for each ecosystem, we developed descriptions for up to 5 succession classes that are defined by species, percent cover, and height. And again, I'll be going into more details, but we also use models to estimate how much of each one of those succession classes would have been on the landscape prior to major European settlement, or with natural disturbance regimes, however you prefer to think of it. So I talk about models and I talk about descriptions, and it's important to know that they're coupled together. So we have descriptions of each biophysical setting or reference condition ecosystem that you can download as a PDF. And I'll give you a little bit of guidance on how to do that. But if you prefer just to read a document and have it in a PDF form, you can do that. These descriptions go through the geographic range, the sort of biophysical site conditions, that is the climate, the soils, the drainage, the superficial geology that would guide mappers as to where a particular biophysical setting might be. It goes through disturbance information and sometimes has a little bit of information on current issues. So again, these descriptions are focused on reference. Also, as you probably gleaned from my earlier comments, these descriptions contain information on the succession classes. Another way that you can get the data is through what we affectionately call the model tracker database. When we initially developed all these descriptions, we ran dozens of workshops across the country and worked with hundreds of experts, probably some of you, to help with this work. I do not want to imply in any way that our little team developed all of these. We worked with tons of people, and we were kind of the border collies, if you will, shepherding all the information into the model tracker database that we then also delivered as a PDF file. So if you prefer to work in Access, you can do that with this model tracker database. It allows you to do some queries, and I find it a little easier to find the information. That said, we don't provide really any technical support for this, but we'll try to answer questions if you have them. So here's what the models look like in sort of a schematic, and I hope this will help you sort of frame what you think of with the models. So here's a state and transition drawing, if you will, for the north central interior dry music oak forest and woodland. This is a model developed by Greg Nowacki of the Forest Service, and you can see that we have 5 boxes: prairie, savanna, woodland, oak forest, and the mesophytic forest. And for each one of these succession classes or boxes, we defined the duration, so 0 to 5 years, 6 to 50 years, and so on. In the model tracker database, we describe these succession classes in terms of the vegetation, the height of the vegetation, and the canopy cover. So as you might expect, the canopy closure or cover in the savanna is much lower than it would be for the oak forest succession class. The black lines indicate succession, or what would happen to a succession class without disturbance. Excuse me. And the red lines indicate some of the disturbances in this model. So you'll see that I've sort of indicated an illustrative fire disturbance in the savanna. And I want to mention that our disturbances include all natural disturbances, whether it's beaver herbivory, flooding, hurricanes, insects, pests, diseases. So it's not just about fire disturbances, even though that's what I've highlighted here. For each one of those disturbances, we defined an annual probability, which is sort of another way to think of the return interval. So if you have an annual probability of 0.1, it would be a 10-year return interval. So in the savanna, Greg Nowacki, based on literature, his knowledge, said that the savanna succession class would have a surface fire every 10 years or so. So that's sort of visual representation of the model. And here's what they look like more technically. In the original modeling effort, we used VDDT, or Vegetation Dynamics Development Tool. That particular tool evolved into PATH and now has evolved into STSIM. Unfortunately, right now, I don't think you guys can get that software. Stacy is working hard to help you with that, but it's not on the accepted list yet. But if you want to explore this model via a WebEx, I'm happy to do that with you. If you want to dig into a particular biophysical setting and go into the model, we can do it via WebEx until we get this on the accepted list. But so again, each one of those boxes represents a succession class. The green line's succession, the blue line's disturbances. And if you click on a box, you would get a table where we would input all the disturbances. And we ran the model for 1,000 years to get those expected percentages of succession classes for each biophysical setting. This is not to say we were trying to model from 1880 back to 880 AD, but it was to run the model long enough so that things would equilibrate. I don't know about you guys, but if someone had told me I would be modeling a few years ago, I would have run, thinking it was really difficult and hard and above me. But STSIM makes it fairly easy, and I think within an hour of working with you, you could be up and playing with the model and adding in logging or putting in real current conditions to play with the model going forward. So I want you to feel encouraged to go into STSIM once it's on your list of accepted software and play with the Landfire models. So we did this work for a lot of reasons. One is that we wanted to be able to compare reference conditions to current conditions. So here's sort of an illustrative graph for a western hemlock biophysical setting out west. So you'll see in the light gray bars the model reference conditions or percentages of each succession class. Then you'll see the dark bars, which represent current. For this graph, probably as of 2010. And you'll notice that for this western hemlock, there was a big shift. We have a lot more of the shorter closed canopy tree succession class than we would have under reference conditions. This is presumably because of logging. So Landfire does not provide the why. That's for local people to determine. So when you want to go get the models or descriptions, you're going to go to landfire.gov, and if you look at the top, I'm going to try to use the pointer here to help you follow along. Here, I'm going to draw actually. So if you go to the home page and then hit vegetation data, then you'll find a link for biophysical settings, models, and descriptions. And then eventually you get to this page. And we'll send you this link, so don't feel like you have to grab it right now, but That's how you navigate to it. And there are options. You can click on a map zone map, which I'll show you in a moment, to just get a geographically based zip file that includes the PDF of all of the descriptions and the VDDT files if you want to try the older software, and metadata information. Also, you can get the descriptions in the Access database, or if you're into the modeling, you can get the STSIM master model database. So I see that someone has raised their hand, and if there's something I can clarify, I would be very happy to if you can type it into the chat box. And again, I'm hearing myself 5 times, so I really have no idea what I sound like to you guys. I might be saying all sorts of things. All right, so on this slide, here is the actual place where you will go to get those things that I mentioned on the previous slide. I hope you can see this map. These are Landfire map zones, and so if I were to click on this map zone 51, I would get the PDF descriptions of all the biophysical settings for map zone 51. And the database that goes into VDDT. If you look down a little farther, you can see that if you want the database with all the information for the whole country, the lower 48 with Hawaii, you can click here. If you're working in Alaska, you can get that as a separate database. If you want to get into STSIM, you would click over here. Again, Stacy and I are working very hard to get STSIM on the accepted list for you guys. All right, so I wanted to summarize the models for you. They represent how the ecosystems of the U.S. looked and worked prior to major European settlement. So they are not about today's vegetation necessarily. They don't include invasives or logging or grazing or fire suppression. So it's very easy to add that information in. When I say models, I'm sort of generically referring to the technical model, which you would run in the modeling software, and the description that goes with the model. Importantly, we are not saying that these models and descriptions are a prescription for how things should be today, and we're definitely not modeling climate change. That said, we feel that this information provides important context for management. And because the models are fairly easy to work with, you can customize them to capture today's dynamics and to model into the future if you have the information needed to parameterize the models. So with that, I'm going to move on to the spatial data. So Landfire, as I mentioned, delivers dozens of spatial data sets. And you'll notice that I've got them grouped here. And for you guys, I often think that you might be very interested in the environmental site potential and biophysical settings data. So I'm going to spend a moment to describe those. Also, I'm going to show you some example existing vegetation type data sets. And we also deliver several historic fire regime data sets. We do not deliver anything like wildfire risk on the landscape today. So people will often take Landfire data to model that. We also deliver yearly disturbance data sets, which are fascinating. So you can go into the southeast, for example, and see tornado paths where vegetation was reduced from trees to herbaceous. It's really fascinating and for some areas sobering, but I wanted you to be aware of that as well. So here's a map of the biophysical settings for the United States. There's hundreds of them, so I did not try to include a legend here, but wanted to show you this so you can see sort of some of the patterns. The biophysical settings data set was built from the environmental site potential map. The environmental site potential map would be most closely related to a climax vegetation map. That is, what would happen on a particular place if you were to consider soils, superficial geology, climate, and other sort of abiotic factors without disturbance. The biophysical settings map takes that and then incorporates disturbance. So some sites may be mapped differently if you consider disturbance. And this data set is linked up with the descriptions and the models I mentioned earlier. So if you go into an area and make a map of the biophysical settings, you can then learn about those specific biophysical settings by looking at the map, the models, and the description. So just to zoom in a little more for fun, this is the Southwest, and I think it's fascinating to look at these maps. I spent time in northern Arizona, and I agree with the basic patterns here. I haven't zoomed in a whole lot to see how Landfire did in terms of mapping biophysical settings. I also did not go in and adjust the colors. So if you're visually impaired, I apologize. This may be difficult. Or if you don't like pink, this may be difficult. With that, I also want to say that Landfire data, while delivered as 30-meter grid data sets, is designed for large-scale use. What I see is people falling victim to my favorite pixel syndrome. That is, they zoom into their backyard or a stand that they've managed for 30 years or a place where they, had their first hike or something like that. And if Landfire mapped that small area incorrectly in their minds, they ditch the whole data set. I see that happen a fair bit, so don't fall victim to that. Landfire is designed for large-scale use. We do encourage review of the data sets, and there are tools available to help you modify those grids if you have information that suggests that particular pixels should be labeled differently. So again, we're happy to help work with you on that. And for the Northeast, I did make a legend so you can sort of see some of the names of the biophysical settings and to get a sense of their sort of thematic specificity, if you will. And you'll notice some basic patterns as you go south into southern New Hampshire, Massachusetts. You're going to see the central Appalachian dry oak pine forest, which is much more fire dependent. As you move north, you're going to find more of the boreal biophysical settings in the northern hardwoods, which are the northern hardwoods are not fire dependent. So I'll let you take a look at that and offer or remind you to write any questions in the chat box. All right, thank you. So connected to the biophysical settings data, in my mind, are data sets such as fire regime groups. Basically, fire regime groups and mean fire return interval from Landfire and some of the other historic fire data sets are an attribute of the biophysical settings data. So for each biophysical setting, we have a mean fire return interval. We have fire regime groups, which indicate severity and frequency. And we have some other data sets as well. So the mean fire return interval data set is delivered in 10-year increments for the most part. And this mean fire return, and this, fire regime group is we have five groups. And so again, this is historic, and you can explore this data set to learn about fire in your area. As I mentioned, Landfire also delivers several current vegetation data sets. This one here is the existing vegetation type, and you'll notice that the legend is greatly simplified. So the mapper here used the National Vegetation Classification System subclass attribute to make this map. You can, if they had mapped existing vegetation type, there probably would have been hundreds of types. So with that, I want to point out a couple of things. The existing vegetation type data set is usually a few years behind. So we just delivered the 2012 data sets. It takes a while to get all this stuff together and posted. Coupled with the existing vegetation type data set would be existing vegetation cover and existing vegetation height. And what we see people do often is mash those data sets together, then pull out combinations that represent habitat for a species, for example. Thanks for that discussion, Sharon and Stacy. That's very useful. Thanks for looking into that. So here's the cover, and you can look at the legend and see how we split out cover. So to summarize the spatial data sets, Landfire uses the best science we can. It's an all lands data set, meaning it's wall to wall. It's not just Forest Service or not just Nature Conservancy or not just BLM, or it's all land. So that's one of the biggest sort of beneficial attributes in my mind of Landfire data. We're not just fire. We are vegetation, historic and current, and we are historic fire and current fuel data. We're here to help as much as possible, and so I'll have some contact information for you, and we're happy to share all the links with you as well. So getting the spatial data. Stacy's been working on this as well. There are two ways. One, which is my favorite and may or may not work for you because of the sort of accepted applications list that you have, is the Landfire Data Access Tool, which is a toolbar that rests at the top of your ArcMap interface. And it allows you to draw a rectangle around your area of interest and then select the data sets you want. And then it has a little assembler that puts the raster data sets together. It's really clever, and there's a great tutorial on it. Also, you can go to the Landfire Data Distribution site, which is highlighted right on the homepage of landfire.gov. It's an online interface that also allows you to grab the data if you cannot use the data access tool or prefer to just work online. The Landfire YouTube channel has tutorials on both methods put together by Jim Smith. Let us know if you have any problems. And I'll also note that you can go to landfire.gov and download a mosaic of the whole country for many of the data sets. I failed to mention that on this slide, but that's one of my favorite ways to get the data. There are large data sets, multiple gigabytes, as you might imagine, but once you have them, and you can clip out areas, do all the manipulations you want to. So that's another way to get the data. So to summarize, before I pass things off to Stacy, Landfire delivers 30-meter pixel raster data sets covering vegetation, fire, historic and current. The data is designed for large areas, watersheds, for example. I have drilled down to smaller areas with partners, but that's only after we've reviewed the data, made adjustments, and understood what's happening. We understood the strengths and the weaknesses of the data. And also, I didn't really mention this, but one of the most used data sets is the topographic data set. It's mosaics together for the country, and it's beautiful. So dig into the Landfire data sets, explore them, let us know if you have questions. Also, as I alluded to earlier, many of the Landfire data sets are updated. And here's a table sort of illustrating the versions. And I encourage you to go to landfire.gov and dig into this a little more. But Landfire basically updates the data every 2 years, and that was started in 2008. And so with this, you can go in and, again, for large scales and with appropriate review, you can look at trends. We do improve our mapping methods, and things do change methodologically from version to versions to some degree. So doing comparisons comes with the fine print of needing to do the review and your due diligence. But it is pretty amazing to me that Landfire updates the data for the whole country every 2 years. You'll also note that we have a proposed remap coming up. And I want to mention that because we hope to collaborate with you guys to help us improve our data sets moving forward. I'll also mention that the Nature Conservancy's Landfire team is working on a review of all of our biophysical settings, models, and descriptions, and we need your help. The models and descriptions were delivered in 2008. We know there's new information. We know there are some blunders in those models. So as you dig into them, please let us know if you find issues or ways that we can improve those. We'll also be sharing the link to our website that's used to facilitate that review. As I was telling you earlier, users plus review equals better products. You can submit plot data to us that we use to help update the data. That's very important. As I mentioned, we're reviewing the BPS models, and we have a remap coming up, and we're looking for feedback on how to make our data sets better. So we have landfire.gov, as I mentioned earlier. Then the Nature Conservancy also has the Conservation Gateway, where we house tons of applications and tutorials and stories of how people have used the data. All right, before I give you sort of the last contacts slide and pass it over to Stacy, I just wanted to put this summary slide up and really appreciate your participation. And with that, I want to, again, promise that we'll send these links to you so you don't have to frantically write them down. But wanted to mention we have the two websites I mentioned earlier. We have a very active Twitter feed. We have the Landfire YouTube channel. We have postcards that and bulletins that you can get via email that you need to opt in for. We do not spam or just randomly send this stuff out, so you need to sign in. Also, if you have any questions, there's always landfire@tnc.org. And with that, I think that this is my last slide, and wondered if there are any quick questions before we pass it over to Stacy.
So again, if you have a question, you can put those into the Q&A pod, and we'll ask those. There are several people have asked questions already in the chat, and Stacy's been very good about answering those questions on your behalf.
Okay, Sharon has a really great question in the chat box that I want to point to really quick about general soil polygons and the Sturgo data. It was interesting as we moved east with the BPS mapping, we relied more and more on soil data because elevation, aspect, slope became relatively less important compared to the west. If any of you guys have walked around the Upper Peninsula of Michigan, you know that in a mile you could go from boreal acidic peatland to alkaline conifer hardwood swamp to jack pine barrens, transitioning to red pine, white pine, and then to northern hardwoods within a mile. It's really beautiful but maddening to map. So we depended on soils a lot. And Jed Munier of the Wisconsin DNR is actually using new or relatively new soil fertility, soil drainage data from Randy Shadesell of Michigan State to try and remap biophysical settings. So Sharon, I wanted to mention that because soils are a key part of our BPS mapping, especially in the east. And if you guys ever notice weird things with the soil polygons or BPS mapping, let me know. We're not able to go in and just adjust pixels at a national level. You can, but the Landfire program doesn't. However, if you can provide us soil-based rule sets or guidance on how to map, we can probably work with that.
Randy, there is a question that's come up. It's asking if you would please contrast GAP and Landfire.
Okay. I am not the best person for that, I'll be honest with you right off the bat, but I'll tell you what I know. We have a strong partnership with GAP, so we work with those guys a ton, especially in regions such as the Southeast. We have some of the same mapping and modeling methods and are incorporating lessons learned from each other more and more. And with that, what I should probably do is contact you guys later with more information, because I'm going to go past my knowledge, and I'd rather not do that. Don asked a great question about accuracy assessments. And also, if you go to landfire.gov, you can drill into accuracy assessments. Those, again, come with some fine print. If you've done accuracy assessments, you know that it's fairly difficult. I've worked on one with the Hiawatha National Forest where we compared their ecological land types to Landfire biophysical settings, and the crosswalk was messy. And just if you do true-false comparisons, that is, we map one thing, did the Hiawatha map the exact same thing, you get sort of artificial falsehood in a way. So what we did was we added in a close category. But anyways, I invite you to go to landfire.gov, and if you search the search box there, you can dig into accuracy assessments. Jim Smith, who's on the Landfire team, has been a part of those and would be happy to help you interpret those and tell you about the fine print. I see a question from Craig, and I can't see the whole question. Oh, there we go. All right. So not that I know of, Craig. That's a great question. I don't know if you guys can all see it, but he asked, is there any plan to increase detail, expand scale with subsequent updates? Not that I know of. So I think we will be sticking with the 30-meter pixels, and I think our scale guidance / lecture will stay the same. You know, it's designed for large-scale use. I can talk to you more about your landscape and sort of size of use. It's different from place to place, so we're pretty nervous to offer up an acreage number. So anyways, contact me if you want to discuss that more, but that's a great question, Craig. One more quick comment on that. We are looking at ways to increase detail in some of the legends. For example, we're looking into feasibility of breaking the height categories up. I don't know the status of that, but with the remap, we're hoping to provide more sort of conceptual detail where possible.
All right, Randy, I don't see any more questions that come up, but hopefully you'll stick on the line, and if there are some more questions, you can help when those do come up. At this time, we'll move to part 2 of the webinar on utilizing Landfire data to differentiate ecological sites, develop state and transition models, and populate ESDs. This portion of the webinar will be provided by Stacy Clark. Stacy is a regional ecologist with NRCS Full Survey Divisions 10 and 11. She joined NRCS after working for the Minnesota DNR's Heritage Program as a plant ecologist. She received a master's in forest ecology from the University of Minnesota and has worked for the U.S. Forest Service as a forest technician and specializes in riparian and subboreal forest ecology. Stacy is also interested in spatial approaches and tools to analyze soils and edaphic factors for ecological site differentiation and development. Stacy, I'll turn it over to you.
Thanks, Sean, and thanks, Randy, too. Great job, as always, and thanks to everyone who is on today. I hope you're finding this useful and already thinking about some ways you can use this for your soil source and ecological site work. But in case they haven't already occurred to you, I'm just going to point out a few examples. Of course, people are, going way above and beyond with some of this data, so we're not going to cover every possible way of getting at and using the data here. But this webinar, once it's recorded and posted on the YouTube channel, hopefully you guys can just start to get your feet wet. And then, like Randy said, if you have questions, please feel free to get in touch with us. A lot of people have been finding it pretty helpful. So, okay. So I'm going to give you a few examples of how we've been using Landfire with our ecological site work. And the biggest sort of areas of ecological site concept development that we're using the Landfire data in is to help us define vegetation reference community. So once you're doing your soil source and you think you've got some solid groups and you're sitting there wondering, well, what the heck kind of vegetation do I slap on this, or what do I put in my, what's my reference state concept? I think that the biophysical settings can come into play there and help you out. And then also using a few of the other data sets can really help you round out your state transition models. So as Randy noted, so they are transitioning from their old software, which was for modeling of state transition models, which was the VDDT sort of software type modeling system. And they're transitioning to this new STSIM software. And as Randy mentioned, I have been trying to work with IT to get that on the NRCS certified software list, so that as you guys are out there all across the country, you should just be able to download the zip folder of it and open it and install it on your computer all on your own without having to get your IT person involved. Some people have been able to download and install the Landfire Data Access tool. That's an Remap extension, so it shouldn't give you any problems. But then again, I've been talking to some other people who have said that they have not been able to install the Landfire Data Access tool and that they've needed an IT person to come and do that for them with administrative privileges. And some people's IT people have been willing to do that, and some people's IT people have not been willing to do that. So long story short, I included the Landfire Data Access Tool Arcmap extension in with the STSIM software, but they didn't seem to like that either. So anyway, we'll see how it goes. We're working through it. Give it a try yourself, the Landfire Data Access Tool, and see if your IT person can help you with it. But if they're not willing to do it, then we'll just have to wait until we can consult once, and I'll send out an email hopefully once those get certified. So, okay, moving on. So Landfire is currently being used and has been used for the past several years all across the country to help us with development of our ecological site concepts and population of our ESDs. And as I mentioned, the biggest uses that we've seen so far are the biophysical settings, which sort of represent our soil source and our historic reference vegetation conditions. And this particularly comes in handy, as Randy mentioned, if you happen to be in an MLRA where there's not a lot of state heritage data, for example, or if there are no Forest Service ELTs developed in your MLRA, and you just don't have a lot of existing sort of historic mapping of vegetation communities. So this can really come in handy in that case. As Randy mentioned, the scale is a little bit broader than what we might develop for a single ecological site concept, but it is extremely useful to overlay that biophysical settings layer onto your soil source and just to give yourself a good place to start. So especially for this provisional initiative, I think it'll be a plenty, and we'll look at some examples of that later. The other layers that we've been using and looking at are the existing vegetation height and cover layers, and those since those are current day representations, you can use those to help you identify alternative states for your state and transition model. So if you use the biophysical settings, for example, and it tells you that it was a north central oak interior savanna forest system, and then you look at the current existing day vegetation and it says it's all agricultural land, then you know that should probably be one of the alternative states in your state and transition model. Also, it could help you identify potential places to go out in the field to verify your soils legend and develop some information for your state and transition model if you do get the opportunity to go out in the field. So say, for example, the reference vegetation biophysical settings layer says that this is an organic spruce peat bog, and then you look at the existing vegetation cover for what it is currently, and it says also in this one area it is still an organic spruce bog, then that might give you an indication that that area is a good place to go to do some Tier 2 or Tier 3 sampling. So the BDDT model, again, Randy mentioned that that's getting phased out, and we would like to move forward with the ST-SIM, but really there what I was trying to reference was the existing, in the model tracker database, the existing representation of the potential phases. Again, and we'll look at that, an example of that in a little bit, that can help you populate some of the actual information in your different phases or states in your state transition model, help you identify what some of those transitions might be and what some of those disturbance regimes and frequency intervals are, which are really important. Just as a side note, I've noticed a lot of times the hardest thing for us to do and talk about in our state and transition models isn't just the identification of the disturbance or the mechanism, but we really need to figure out and do a better job at being able to explain the frequency and the intensity of those disturbances. So it's not just enough to say, this site is, relegated by a historic fire regime. You want to be able to say it occurred approximately light surface fires every 3 to 5 years. That's kind of the level the information we want to provide. So I think that the model tracker database can help you a lot with that. Also, we'll look at an example. The biophysical settings, the classification system aligns up with NatureServe, and so you can actually go to the NatureServe website and get some information about that class, and that will provide you with information such as species, cover, that kind of stuff, and even some soils information, so you can check and see if it kind of lines up with where you're heading with that particular soils group. So we'll look at an example of that as well. And again, just a quick note, if you do have questions, feel free to raise your hand and type them in. I am actually looking at my presentation in full screen mode, so I'm not seeing them right now. So feel free, Sean or Randy, to just interrupt if there's a question you guys want me to answer. We'll also take questions at the end too, I'm sure. Okay, so this is an example of where we've installed the Landfire data access tool into Arcmap, and it sits right up top there. You can install it as a toolbar. And this is a really great way, as Randy mentioned, to get the data right into Arcmap. Otherwise, if you go to the website and you select a map zone, which we'll look at an example of in a little bit, you'll have to just go through a little bit of a process of waiting for them to send you the zip folder, saving the zip folder to your hard drive, unzipping it, and then importing it into your Arcmap. This way, it imports it right into Arcmap for you, and it already has your area of interest identified. So here I've picked out MLRA, it's one of the 108 in Iowa, I believe, and we are looking at the biophysical settings layer. So here's the information, here's the biophysical settings layer, and you can see the different groups that are represented. So this is the vegetation historically that would have been in this MLRA. So as you can see by the color scheme, it looks like we've got a lot of central tallgrass prairie, which is not surprising. But there's also a decent amount of hydrology there, open water, and we've got some floodplain systems and a few other colors there too. If we were to zoom in, it looks like there might be some sand and gravel tallgrass prairie and a few other kind of cool things in there. So again, this is a really great way to just get a pretty instant assessment of your MLRA if you don't have any other data, or even if you do, to sort of get a really great snapshot historically of what the vegetation would have looked like in your MLRA. So once you have that data, what you can do is you can actually do a little bit of a spatial analysis in ArcMap. So this is an example of where we took our soil sorts, our draft soil sort group. So this column A here, this was from Tyler Stagg's work in 111C. He took his soil sort groups. He had about 20, 24, 25 of them to start off with. And then he overlaid it with the biophysical settings layer, and he did an intersection of, for this group, how many of each of these potential vegetation communities occur in that group. So this can be a way to check whether or not your soils groups are holding up as a group. Again, the scale difference between Landfire and our soil map units is pretty big, so you have to take this with a pretty big grain of salt. But one thing we can see here is that in some cases it is starting to show up that we're getting some pretty strong correlations. So here for this particular group, more so than any other group, much more so than any other group, this soil sort group aligns very strongly with the north central interior beech maple forest. So this is a great way to sort of reassess that group 12. And then we looked at the units that fell into the central tallgrass prairie that we had put in that group, and we did do a double check of whether or not there were some mollisols or molic integrades in that soils group and whether we really wanted to keep them in that group or not. Or sorry, there's group 11 there. So again, this is a great way to just potentially assign a vegetation reference condition to your soils groups, or check whether your groups are, whether you think that they're holding together tightly. Here's a almost 70% correlation for group 10 to the north central interior dry oak forest and woodland, much higher than the correlation with any other group. And so again, that was a pretty good indicator there of the reference condition that was likely for that soils group as well. So once we did that, you can actually take the name of that biophysical settings group and you can go to the NatureServe website up here, explore.natureserve.org. And you can type it in. You can go to the ecological communities and systems. These are ecological systems. And you can copy and paste or type the name in here and click search. So we're looking at the central tallgrass prairie. And then it will actually come up with a description for you of how do they define the central tallgrass prairie. So look here, and it says that this system is found primarily in this ecoregion ranging from Kansas to Indiana, and it gives you all kinds of information. It does talk about the soils being deep and rich mollisols, usually greater than 1 meter in depth. So already you're getting some information here about whether or not this should line up with your soil sort. So if you sorted soils where the depth to root restriction was, greater than 1 meter, and they're all mollisols, and you know, the soil moisture regime was relatively music, then, you know, that sounds like you're probably on the right track here. So then it actually gives you some specific species as well that are characteristic for this plant community. So Budulua and Heterostipa, little blue stem. So these are species that if you feel like this vegetation class fits for your soil sort group, then you can go ahead and actually put these species into your biotic name or put them into the write-up of your reference community phase. Here too is some information about the disturbance regime and what happens when this disturbance regime gets modified, such as fire suppression. There's a hint here about invasion of woody species and conversion to agriculture. So even just in this one first introductory summary paragraph, already you've got an identification of maybe whether or not this is fitting your soils group, a few species that you could put into your reference community phase, and some hints about what some alternative states might be or what the mechanisms for those alternative states might be. Then as you drill down a little bit lower onto the page, it'll talk about some similar classification systems. So if you wanted to get more detail or more references, you could look into these similar ecological systems. If you think maybe this kind of sounds like the one, but not quite, you can look at some of these other ones here. Also, the lower level, so a little bit finer classification for these, it will give you are the associations and the alliances. And so if Central Tallgrass Prairie seems on the right track, but just a little bit too broad for the site concept you're trying to develop, you could try to narrow that down. And so if you decided that, you know what, I'm in the Luss Hills of Iowa, I really think that Indian grass and Hesperosaipa has got to be in there, you know, obviously big blue stems everywhere, but you know, maybe you want to focus more on this Luss Hills Grassland Association instead of the more broader ecological system of Central Tallgrass Prairie. So if that's the case, you could continue to drill down into that data, go back up to the NatureSub webpage, type in this association and alliance, and you could continue to get more specific information about what species comprise that vegetation association. And this is still at the system level here, but this will give you the same information for associations and alliances. And so it'll give you a list of species, what the growth forms are, and whether they're dominant in this system or whether they're just a minor component. Also, I know we're not really doing much with wildlife at this stage, but it is important, I think, to take a peek at this, you know, the animals that are associated with that system. If you can, you know, go ahead and throw them into your write-up of the ecological site concept section of your provisional. I think that, you know, we don't want to ignore the wildlife aspect of it just because we're not doing interpretations yet. So, you know, you could go ahead and use this information if you felt like it fits and like it was appropriate. And also, perhaps one of the most important things is this list of references at the end. So, you know, use these to find more references and more literature and more information about your area. This is a great way to, you know, get some free lit review for your area there and these types of systems. So anybody can go and download this Access database. Once you download the Landfire data, you can get the model tracker database. This does not require your IT person or anybody like that to install for you. So this is also something that you could download and get started on. And so here we typed in the ID for the Central Tallgrass Prairie. And so it brings up the general information here. So a lot of this information could go right into your write-ups for your provisional. So here, geographic range, make sure this fits with your MLRA. And biophysical setting description, this information could go right into your physiographic features and into your soils feature section. The vegetation and disturbance descriptions can go right into the write-up of your ecological dynamics of the site, or right into the write-up of your narratives for your state transition model for your provisional. Please don't plagiarize, though. Just a quick note, please cite Landfire, make sure you're doing all the proper citations, and don't just copy and paste. We got to be responsible, scientific, maintain scientific integrity with that. So make sure you're just doing proper interpretations and proper citing. Then if you go to the next tab, it talks about the classes and disturbances. So this is really what's going to help you define how many phases do I have in my reference state, in my state and transition model. So I didn't do a snapshot of all the phases, but or all the classes, but here they're talking about, if you remember in Randy's model, Greg Nowacki had about 5 boxes and arrows going to and from each of those boxes. Some of those boxes would probably translate as phases in our reference state, and then some of those boxes may have actually translated as alternative states. So for example, that box in Greg Nowacki's model that talked about a mesophyte forest, that could potentially be an alternative state due to, over 100 years of fire suppression or something like that. I'm just using it as an example. I don't know because I haven't specifically looked at that model yet. But you can look at this information, and if this Class A, for example, had 41% of the landscape historically, that's a fairly good chunk of presence there historically. So this should probably be one of the phases in your reference state. So this is a immediately post-fire regrowth stage, about 2 years. Fire return interval about every 3 years. Or sorry, that's the fire fuel behavior model. Here you can look at it's got about 70% canopy closure. The maximum height for the herbaceous layer and the maximum height overall is greater than 1.1 meters. It's pretty much all herbaceous. We don't have any trees or shrubs in this phase. And the cover is ranging from 0 to 70%, but here they say it could actually go up to 100%. So this is a very, couple years post-fire, and here it talks about some space opened up by litter removal, and fire neutral forbs maintain the pre-fire composition but may be reduced. So here this is giving you some really great information that you could put into this phase in your reference state. And here's the actual species that are dominant in this layer. So it looks like big blue stem and little blue stem and a couple others. So this, again, this gives you a lot of information you can put right into your state transition model. This other class has 57% cover historically, and it's a little bit later stage. Again, here the canopy closure is a lot higher. And I didn't scroll through, this is just a screenshot, but 57% is pretty high. You may decide that you want to make this your phase 1.2, and this would be a few years, later without fire or whatever the mechanic is, and you would talk about this phase as well. Some of the phases you'll see, or some of the classes, you'll see in this model tracker have relatively low cover, so some will have even something like 2% cover, 8% cover historically. That's something you're going to have to assess. Typically in our state transition models, we like to define our phases and states as something that would have been, had a fairly significant presence on the landscape. But if you feel like even though it was only 8%, that for some reason it's a very important representation or successional stage for that class, you can go ahead and put it in. But I think this is some really useful information here, some really specific information about species associated with these classes and the disturbance regimes that you can help you use to help you identify phases and states and put some information in the narrative for those and in the mechanisms that trigger those into your state transition model. Also, don't forget, here you can bounce, if you go to the Disturbances tab, that'll give you a little bit more information about the disturbances. Don't forget that intensity and frequency are very important, not just the disturbance itself. And then also relevant literature. Again, if you think you're on the right track, or even if you think you're not on the right track here, you might want to take a look at some of the relevant literature and do some more lit review on your own. Okay, so if you don't use the Landfire data access tool or the access database, or even if you do, this is, Randy mentioned another way to get the data, going to the Landfire website and going to the map zones. Here I selected a map zone and selected download data. And then here on the right-hand side, it's giving me all the layers that are available. So I clicked on the vegetation layer. And you can see here that I've selected the existing vegetation type. So this is where you would select biophysical settings. If you were not using the Landfire data access tool and you wanted to download the data this way, you would select the biophysical settings layer here, or if you wanted to do existing vegetation type, you have to download type, height, and cover as separate groups. Then you click on this little area of interest tool, and you just outline your area of interest. Sorry, I keep forgetting to use the pointer here. So click on the area of interest tool, and then you would just outline your area of interest. Then, as I mentioned, what that will do is that will actually open a window in your computer, and it will download a zip folder for you. You'll have to save and unzip that folder to someplace and then import it into ArcMap. So here I've imported the existing vegetation cover. So I've shown you half of what the biophysical settings look like in this MLRA, and then half of what the existing vegetation cover looks like. So this is a great comparison, again, to sort of help you identify what, not just the historic reference condition, but what else do I need to put into my state and transition model. Obviously, you know, we've got a lot of row crops here in this MLRA, and that's not surprising, and probably some cool season pasture. And a lot of that native vegetation is gone. So this can help give us an idea of what the possible alternative states might be, or where we might want to go out in the field to take some samples or do some more Tier 2 investigating. This is the existing vegetation height layer, so it does look a little bit different. And now we're talking about close-grown crops, and we can see that we're talking about herbaceous heights of 0.5 to 1 meter. So if you remember, in the reference condition, we were talking mostly about central tallgrass prairies that had a height class of greater than 1 meter. And so this gives us an idea that this is likely a less, I don't necessarily want to say less productive, but this is probably some alternative state like a cool season pasture. And then here is the existing vegetation type. So this is going to be similar to if, you know, what the biophysical settings class was, but if it was something not exactly in reference condition. So again, here we're seeing a lot of yellows and purples, and here we've got western, cool, temperate, urban, herbaceous. So that sounds to me a lot like an alternative state. And we've also got the western cool temperate row crops, which sounds a lot to me like corn, which it probably is. So again, this is just some really quick assessment that you can do to help you get an idea of what alternative states you might have in your model. So I want to point out there is a paper that is very, very useful if you've never used Landfire before and you're trying to figure out how this all works and how you can use it for development of ecological sites. You can Google this, or I have a digital copy. If you want, just shoot me an email and I can send it to you. It's a review and comparison of Landfire biophysical settings. and NRCS ecological site descriptions and their potential for shared application. This was done back in 2007. It was done mostly by a group in the southwestern part of the country, but I think the concepts still apply. It's a very good read. It does go over the differences between our state and transition models and the modeling system of Landfire. And so that's also a good guidance tool for you there as well. Just want to point out that this is one of the first sections of the paper. There is a bit of a crosswalk, so don't assume that each succession class that we looked at with their percentages on the landscape may not be an exact one-to-one phase of your state. So you may decide to lump some of them together. You may decide that one or two of them belongs really in another alternative state of your model, like the mesified, forest, for example. Here, nature serves ecological systems. This is if you're not using the biophysical settings and you're using existing vegetation, or if you're just using nature serves ecological systems map, that is current day vegetation. So again, biophysical settings is historic, and any other map from NatureServe or the Landfire existing vegetation is current day. So that could potentially be non-reference. So you have to be careful about which vegetation layer you're using and whether it's reflecting current day vegetation or historic vegetation. And with that, we can open it up and take any questions.
All right. Well, Randy's been covering questions as they came in the chat there. There was a question regarding would also overlaying not only BSPs, the existing vegetation add to the richness of the community type?
Sorry, let me see if I can find the question. I'm not sure I understand.
It's right there at the bottom chat.
Also overlaying the vegetation and okay, I'm not sure. I'm not sure, Nels, exactly what you're getting at there.
Yeah, I was thinking that if I understand your point correctly, Nels, it was you would take an area and you would get the BPS data for that area and the EVT data, and cumulatively you might be able to paint a more thorough picture of that area by having the novel or new designations captured in the EVT, such as invasives or ag or plantations, or maybe some ecosystems that have changed over time. For example, due to fire suppression, your red and white pine forest might be, or oaks especially, might be converting more to red maple that Landfire might pick up. So if that's how I took your point, Nels, and it's something I honestly hadn't thought about before.
No, he thinks you covered it.
All right.
Yeah. Okay, great. Yeah, I mean, I do believe that people are going to want to use both. You're going to want to use the biophysical settings layer and the existing vegetation layers to really give you a good understanding of not just what was your potential historical reference condition, but what is it like today and how many alternative states are you looking at? And then also it could give you a good idea of where you could go out in the field to try to sample some of those.
I've wondered, Stacy, if you or others have used the environmental site potential data set.
That one I haven't used as much. Personally, I usually just use the biophysical settings one, but Randy, if you think that there's additional merit to using the existing potential one, that could be interesting too.
Yeah, I personally don't have a whole lot of experience with the environmental site potential data set, and I think you're right to use the BPS. because disturbance is real and it does incorporate that, but I was curious if other people have tried it.
Yeah. I mean, we've just seen too many cases, like you mentioned, where aspect or really dissected landscapes or river breaks come into play. And, you know, it's an important, like the fire just did not carry through those. So, you know, I think it's a better fit. So Sharon has a question. Have you found that for a given SurgoMap unit, some polygons have one ESD as a good fit and others maybe a different ESD is a better fit? So this is a little bit of a complicated question because, so as you guys know, we correlate components of map units to ecological sites so that it is possible that in one SurgoMap unit, because there's usually multiple components, we could have multiple ecological sites correlated there. So on a map unit scale, absolutely, it's not one-to-one ES ecological site to map unit, it's ecological site to component. And even then, we're finding that we may phase or have to phase some components so that we could account for more than one ecological site being correlated to that component due to things that we just historically didn't account for in the database, such as aspect or lake effect or things like that that are really creating strong differences in the plant communities or in the production. So there is no guarantee that from one map unit, you know, you're only going to have one ecological site per map unit. It's ecological site to component, and map units can be complexes, so absolutely. I'm wondering, though, if what Sharon's getting at is if you have the same component in multiple map units, have you found that the ecological site for that component is appropriate in this map unit but not appropriate in another map unit? And yes, we found that to be the case, especially I can give a recent example. In MLRA 103, we've got map units that cross into what we call the Big Woods territory. So this is an area where historical river breaks prevented fire from traveling east into an extremely dissected, higher relief landscape. And the fire just didn't historically carry across those breaks. And so this is a small portion of the MLRA that's referred to as the Big Woods. The rest of the MLRA is pretty much prairie. And those map units, because they're the same soils, they just didn't, you know, they didn't create a new map unit or anything for that, for the Big Woods. And so this is where we're looking at doing an MLRA update and possibly creating, you know, doing something like either creating an LRU or separating out those map units and components that are in the Big Woods from the map units and components that are west of the Big Woods so that we can properly correlate a more forested site concept inside the Big Woods where fire did not historically go. So, and if we look at the biophysical settings layer of Landfire and the historic fire intervals, I think that that data, along with the U.S. Forest Service LTAs and subsections and the ecoregions data, strongly supports the Big Woods being historically wooded as opposed to prairie outside the Big Woods where the fire carried more easily across the landscape.
So Nels made the comment that he was sure that the soil properties probably correlated better with some map unit polygons. Let's see, I don't have the right one here. You would imagine that soil properties correlate better with plant communities than just soil taxonomy does.
Yeah. So we usually recommend, of course this webinar is not about soil source, but we usually recommend there's a set of properties, they're called the Super 7 or the Super 8, that people use when you're downloading, when you're doing a data dump for starting your soil source. If you want, I can send you that list. There's columns and NASIS that we recommend, you know, pretty much everyone's going to want to use. And those are things like soil texture, depth to root restriction, parent material, landform, drainage and flooding and ponding, which are all interpretations, but those kinds of things. Soil order can help if you're talking about the difference between, mollisols and alphasols, or something that was historically developed under conifers versus hardwoods. Those kinds of things you can glean out of the soil taxonomy. But again, you have to be careful with that because, we've seen, in the prairie forest transition zone, for example, it gets a little complicated using that kind of stuff. So, yeah, there's all kinds of data. I mean, it's that's a whole separate topic, soil sorts. So, yeah, we could go on a whole nother hour.
And it was just been added that the Super 7 properties listed sand, silt, clay, coarse fragments, organic matter, bulk density, and the water states. Water states include several, but those are listed there in the chat. There was another question. Sharon asks, would you like to be able to tag the polygon to keep this relationship preserved?
Stacy, that would be all you.
I don't know. I'm not sure what that refers to. I've never done that.
Well, Sharon's typing some additional information in. Says this would make better use of the soil geography part of Surgo. This would make better use of the soil geography part of Surgo.
Yeah, I guess I'm not clear on why you would tag a polygon or what exactly. I don't know, Sharon, if you want to expand on that a little bit. Okay. Yeah, sorry. I'll have to plead my ignorance on that one. Sharon will educate me on that later.
Well, I see some others are typing stuff in. We'll give them a moment to finish their typing. All right, well, maybe they're not coming. Last call for questions.
Well, Randy here, I wanted to again thank you all for participating, and I'll be sending all the links to Sean and Stacy to distribute back out to you guys. And also, I'm going to follow up on the gap question. That's a really good one. Also, in the past, I've had questions about how the National Vegetation Classification System links up to Landfire, and we have a pretty good discussion of that on landfire.gov. So yeah, we'll be passing that out. And Henry, great question. What version of Arcgis does the toolkit need? We have multiple versions of the Landfire Data Access tool. So I think it goes back to 9.2, but all the way up to 10.3, I believe. I'm not positive on that. But if you were to Google Landfire Data Access tool or go to landfire.gov and search for it there, you get more specifics. But I believe we're pretty up to date on the different versions that will work.
All right, well, I'm going to echo Randy's comments and thank everyone for their participation today, and thank you to Randy and Stacy for their time and effort to make the presentation today. We had over 75 logins in today's webinar, and the on-demand recording of this webinar will be available on our National Soil Survey Center YouTube channel within a couple of days. So feel free to let your colleagues know about this training opportunity, and this will conclude our webinar presentation.